Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Bharsat, working as Assistant Professor in Chemistry at Maratha Vidya Prasarak Samaj, Nasik. In this video lecture, we are going to see hydrolysis of salt of weak acid and strong base. Now, consider, for example, hydrolysis of sodium acetate is a salt of weak acid and strong base. Okay, so when the sodium acetate dissolve in water, it undergoes complete dissociation. Okay, it you will take sodium acetate in water, so it will be separate out. Okay, sodium acetate. So in this way, you will see sodium acetate. Okay, CH3COO Na. So it will dissociate like this: CH3COO minus plus Na plus. Okay, so in this way you will get the ions, while acetate ions will react with some of the H plus ions from slightly dissociated water to produce the freely dissociate acetate acid. Okay, we have now the sodium acetate we have taken into the water. So in the water, ions are present of H2O. So if you will see the dissociation of water, so you will get H plus and OH minus. So some acid ions will be react with the H plus ions. Okay, so like this acetate group. Okay, this is the acetate group, and the H plus, which is you will get from water. So you will see the formation of acetic acid is there. Okay, so like this reaction you will see in the, if you will take the sodium acetate into the water, and that's why you will see to maintain the constant value of ionic product of water will be there. After dissociation of water, concentration of hydroxyl ions will be increased, because you will see the dissociation of H2O, that will be the H plus and OH minus. So H plus will attract towards this acetate group. That means OH minus ions will be increases. The concentration of hydroxyl ions will be increases, because of we have no the H plus will attract towards the acetate group. Okay, and OH minus will remain as it is. So the concentration will be increased there, and so that the solution becomes basic in nature due to the hydroxyl ions. Obviously OH minus ions will be increases, so the condition of this solution will be alkaline or basic condition. So therefore hydrolysis reaction of sodium acetate written as like this. You will see overall reaction in this case: CH3COO minus plus Na plus H2O. It gives acetic acid, right? Na plus and OH minus. And by cancelling the common Na plus ions on each side, okay, Na plus is here and also this side, okay, right hand side and left hand side, so they will get cancelled. After cancellation of Na plus, remaining molecules will be acid group and water molecules, okay, to the left hand side, and here acetic acid and OH minus will be remain to the right hand side. So by applying the law at equilibrium and taking the water concentration is constant. Okay, so water molecules we have to take as a constant here, and remaining we have to apply law of equilibrium. Okay, so we have now the concentration of product divided by the concentration of reactant. Okay, that is the KH. Okay, that is hydrolysis constant of salt. So in this way you will take in bracket CH3COOH bracket complete, and here OH minus, okay, in bracket OH minus, divided by, so this side, okay, remain molecules we have to write here, and left hand side remaining molecule acetate group is there only, so you have to write in bracket that. Okay, so is equals to, so this is the free acid and this is the free base. Okay, acetic acid and OH minus, this is from the base, or you will say this is from the water, an unhydrolyzed salt. So this is the acid group, it is unhydrolyzed salt. So in this term the KH is the hydrolysis constant of salt. Okay, now for this solution, if you will give the temperature, okay, what we have taken sodium acetate plus water, and to that solution if you will give the temperature, so the constant values, characteristics of constant value will be changed. Okay, and you will see the ionization of weak acid here. Okay, acetic acid is the weak acid. Dissociation of weak acid, you will see CH3COOH. Okay, so you will get ions CH3COO minus plus H plus. So this is the ionization constant of weak acid, that is you will say Ka. Okay, Ka, that is the ionization constant of weak acid or for the acid. Now by the law, okay, you will arrange concentration of product divided by the concentration of reactant. Okay, so this side you will write here, okay, and this side you will write here below. Okay, so in this way we have to write. After that we have now the ionization of pure water, and we have now the molecular formula for the water. Okay, it will be in a liquid form, so you will get ions H plus plus OH minus. Okay, now again you will apply the law, okay, to the ionization of water, ionic product of water. So that you will say the ionic product of water, that is Kw. It gives concentration, or in bracket H plus plus in bracket OH minus. Okay, that is the concentration of H plus plus the concentration of OH minus, and dividing the equation, this one Kw divided by Ka. Okay, so the ionic product of water divided by the ionization of weak acid. Okay, that is weak acid. So you have to write as it is whatever the product. Okay, so the ionic product of water, the whatever the given, okay, concentration of H plus plus concentration of OH minus, we have to write as it is. And for the Ka, that we have written here. Okay, H plus and concentration of H plus will get cancel. Okay, and this acetate group will be here, and this acetic acid group will be go to the above side, so that you will write in this way concentration of acetic acid into the concentration of OH minus and divided by the acetate group. Okay, concentration of in bracket acetate group. So it will be the KH. KH means what? Hydrolysis constant. Okay, hydrolysis constant for the salt. So that you will write in this way Kw and divided by Ka, and hence hydrolysis constant of salt of weak acid and strong base is inversely proportional to the ionization constant of weak acid, that is Ka. Okay, ionization constant of weak acid, that is Ka, we have taken here. Okay, now we have to see next topic, that is degree of hydrolysis. Now consider the hydrolysis reaction of salt. In that you will see C, okay, small c. Small c stands for initial molar concentration of salt in the aqueous solution, and H stands for degree of hydrolysis of salt. Now we have to see the definition for the degree of hydrolysis, that is the fraction of total salt molecules that undergo hydrolysis at equilibrium. Okay, so whatever the salt molecules will be there, the fraction of all the total salt molecules that undergo hydrolysis up to the equilibrium condition. So in this way you will see salt, okay, sodium acetate, this is the salt. If you will take that into the water, so it will get dissociate, okay. Dissociation we have seen CH3COO minus and Na plus, okay. So from water will give H plus to the that acetate group and will form here acetic acid, and side product is NaOH. So in this way you will see here initial molar concentration is C for the sodium acetate or salt, okay, and here acetic acid initial molar concentration is 0 and NaOH is 0, and the concentration at equilibrium you have to consider small c in bracket 1 minus H, and here for the acetic acid CH, capital not capital small ch, okay, and here again small ch. So therefore the hydrolysis constant, that is the Kh, okay, hydrolysis constant means Kh. So you will write for this reaction, okay, in bracket acetic acid into the in bracket NaOH, this one the concentration of whole product we have taken here, okay, and here concentration of sodium acetate only, and water we have taken here as a constant. So we have to write in this way acetic acid and NaOH, the concentration at equilibrium, okay, CH into CH we have to taken as it is, and for the sodium acetate is small c in bracket 1 minus H. So you will write in this way C into H square and 1 minus H, because of this C and this C will be get cancelled, okay, and remaining 2H and 1 C, so C into H square, and here 1 minus H only. And if H is very small as compared to 1, then the 1 minus H approximately is equal to 1. That's why we can write here hydrolysis constant, that is Kh is equals to C into H square divided by 1 minus H, and is equals to C into H square. So the degree of hydrolysis, that is H, you will write in bracket Kh divided by C. So you will say here the degree of hydrolysis of salt is inversely proportional to the square root of the molar concentration. And next step you will see the combining the equation, okay, we get another relation of degree of hydrolysis, okay. So we have seen two equations for the degree of hydrolysis, okay. So first equation you will say Kh is equals to Kw upon Ka, this is for the first, and second is we have seen here, okay, this one, okay, under root of Kh divided by C. So you will write in this way H is equals to under root of Kh divided by C, and is equals to under root of Kw upon Ka divided by C. So you will get here H is equals to under root of Kw divided by Ka into C. And this equation we can use to calculate the degree of hydrolysis of salt of weak acid and strong base at any concentration of salt by knowing the ionization constant of weak acid. Okay, ionization constant for the weak acid we can denote by capital K and small a that we have known. Okay, so denotion we have to remember KH hydrolysis constant and H is also hydrolysis constant here, and Ka is ionization constant of weak acid and Kb ionization constant for the base. Okay, now we have to see what will be the pH of salt if you will add weak acid and strong base. Okay, so what will be the pH of that salt that we have to see. Due to hydrolysis of salt of weak acid and strong base, the salt solution becomes alkaline. Okay, salt solution will be alkaline. That means the OH minus ions will be more there. Okay, OH minus ions will be equals to C into H. And in this equation you can write also Kw divided by in bracket OH minus also. Okay, and ionic product of water, that is Kw, it gives H plus concentration of H plus and plus concentration of OH minus ions. Okay, this is the dissociation of water. Okay, now substituting the value of equation degree of hydrolysis, that is small h, and this value. Okay, we have to substitute both values. So in this way you will take here in bracket H plus divided is equals to Kw divided by small c under root of capital K small a into small c divided by Kw is equals to under root of Kw into Ka divided by small c. Now taking negative logarithm of both sides of this equation, so you will get minus log in bracket H plus is equals to minus log under root of Kw into Ka divided by C is equals to, you will get minus log in bracket Kw into Ka divided by small c and bracket 1 by 2 square. So that you will get now pH is equals to minus half log in bracket Kw into Ka divided by C is equals to minus 1 by 2 in bracket log Kw plus log Ka minus log C, and after that you will get pH is equals to minus 1 by 2 in bracket minus log Kw minus log Ka plus log C, and last pH is equals to 1 by 2 in bracket pKw plus pKa plus log C. So finally you will get this equation for the pH, that is 1 by 2 in bracket pKw plus pKa plus log C, and this equation we can use for the calculate the pH of salt of weak acid and strong base by knowing the concentration of salt, the ionic product of water, and ionization constant of weak acid. Ionic product Kw, okay, and ionization constant for the weak acid, that is Ka. So we can calculate this way.